Yes, before we start, I would like to thank each one of you for making it, because there's a big storm outside. And I think we need to clap each other, for yourself, because you guys are the warriors for making it. Yes, today I'll be basically talking about my experience. Recently I tested out a few of my learnings, and I'm going to talk about what I learned and what are the good things which I learned. So before that, I want to know how many of you have worked on PWS, Progressive Web App, with application of it. How many of you have heard about PWS? Okay, a lot of people. I think then I don't have to go into what PWS is and what are the advantages of that. How many of you have tried optimizing your mobile web or a desktop web? Okay. Okay. Yeah, good number. Okay. So do you use Chrome, Firefox? How many of you here are Chrome users? Oh, good number. And Firefox? I'm sorry, but yeah. Yeah. So do you dig into your DevTools? How many of you really go into the DevTools not just to inspect your DOM, but to see your performance, like memory leaks and stuff like that? Good number. So yeah, basically I'll be talking about those aspects. Hopefully I don't bore you guys. So I'll be going into how I made my one of my experiment app faster. So that's what the talk is all about. Telling you about me, I'm Narendra. I work for a company called Booking.com. How many of you have heard about it? Yeah. So yeah, we help you find the best best hotel room across the world. So that's me. I work as a front-end developer there. Next one. After this talk, I've actually hosted my slides on this URL. So you can all go and see it. Yes, that's me. Okay. Yeah. The motivation. Why did I do it? Like each one of us, I've read a lot about PWS, a lot about web performance, advantages, disadvantages. But the thing is, I never had a chance of implementing it, either in my company or any of my projects. So what I did was, the main motivation behind this was to really implement what I've learned, what I've heard, and all the theory knowledges. So giving a bit of background about why I started. Recently, Alibaba, I think few months ago, they launched their mobile web. It's a PWA mobile web. They had a very interesting metrics to see. One is the conversion. After they launched their mobile web, they had a 76% of increase in conversion, which is a huge. And not just that, they also had not just having a conversion, they also had an engagement where a lot of people actively coming into the mobile web, which is 14% on iOS and 30% on Android. So this was the advantage of mobile web for them in Alibaba, because back in China, a lot of people use Android phone, and you have good access there. The second company I'm going to talk about is the Housing. Housing is an Indian online real estate company. They had a very interesting metrics. One is the user acquisition cost. If you all know, this is not very important for us developers, but for a marketer, this is very important. In Android, they spend nearly $3.75 to acquire one user onto their app. Any guesses how much would they have spent to acquire one user on their mobile web? You can take a random guess.
30 cents.
30 cents or something like that.
Any other guesses?
50
It's 7 cents. Yeah, you can take a screenshot. Yeah, please.
But you're talking about just mobile web? I mean, before they didn't have any mobile applications?
No, they didn't have anything.
Okay.
They started with their PWAs.
They started
Yeah, it's a pretty new company, and they had their apps and the desktop thing, but they had a basic mobile web which was not good enough. But once they optimized their mobile web for a PWA, this was their metrics. So this is basically from the Google Web Summit, which recently they gave a talk about. These are the informations from them. So you can actually talk to your marketing team about this and really implement PWA in your company.
Yes.
Not just this, but they also had other improvements like the 30% page load. This was from their previous mobile web to the PWA, and the increase in conversion. So 38% increase in conversion. And there's another company called Lyft. It helps you. It's like an Uber. It helps you get a cab. It's a different metrics which we'll be looking at here. The size of their mobile Android app is 17 MB, iOS is 75, where PWA is less than 1 MB. And they definitely, but very few months ago, they launched their mobile web and not PWA. And they saw a 5 times increase in ride taken by compared to apps. So they are actually investing a lot of time into PWAs. And I think it's in beta right now. They've not launched it completely, but they'll be coming out soon. So there are a lot of other companies who have integrated PWAs. So these are all the list of the companies. So this was basically the motivation of why I started doing it. So what I did, I built an app called Uber. I built the entire Uber app into a mobile web using the Uber's API. Uber's map API. I've used the web Mapbox GL, which uses the WebGL technology. Uber has a React component, which is a wrapper around this Mapbox GL. So I've used that and I've built this web app. Mostly just to test out my learnings, mostly test out the PWA or the web performance techniques which I've learned. So that is what I built. And all the measurements which I've done from now onwards, it's done using the Lighthouse, which is a Google Chrome's product, which is built basically to optimize your mobile web. So basically after building this app, I tested out on that tool, and this was a metrics. So the main metrics we'll be looking at here is the first meaningful paint. First meaningful paint is something which you would see as a user. That's the first content you would see on the screen. So that's the first meaningful paint. So that's something user is, you would actually interact with the user for the first time. So it's not interactable, the JS is not completely loaded, but that's something which is there. So this was 19 seconds. The Uber app took 19 seconds to load. So from there, I'm going to talk about how I really optimize it. So on a regular 2G networks, this is how it loads. You don't see the Uber logo for a while. Yeah, so I'll skip for the next slide, comparing it with how I optimize it. So that's how it is in the same network speed, and that's the difference. The left one, what you see, is a 19-second speed, and the right one is the screen which is loaded first. And now it's loading the map, so that's why it takes the time, the second screen, and then the map's loaded.
Why 2G?
Sorry?
Why 2G?
A lot of networks, what I'm testing is on regular 2G, because not 3G, because this is basically from India and China, where 3G is not very famous. So mostly I am from India, and I've seen the problems with 2G networks. So that's about it. Okay, now the map's loaded there. So yeah, not loaded. Now the Google's taking time, so it's not my problem. Yeah. Not just that, it also is accessible on the offline, where once your assets are loaded, you can just load it where the map's not accessible, but a lot of other things are accessible, like if you have access to your payments or settings. So a lot of these assets are already loaded, so you can access all of that. So this was the offline access. So after this, I've tried a lot of techniques to improve this, but I will be talking about the 5 important techniques which gave me the maximum impact, which are these. You might have heard all of these techniques by now, and you know all of this, you might have implemented all of this, but I want to talk about how the impact was each one of these techniques on my app and how much advantage I had with this. So starting with code splitting, I've used Webpack for that, and with React Router, you can pretty much tell that where exactly you can split your code on the router base. So code splitting, I've used Webpack here, and there are 2 ways to split your code. One is the route based chunk, as I mentioned, if I'm, for example, on the home route, you get served only the JS or the assets which is needed for the home route, and when I go to the book route, you get that. So whenever you run that particular route, you get served that particular route's assets. So that's route-based chunk. This is by the default React routes syntax, where you import it. The main important two things which you are looking here is just the import and the usable. So component API of the route, you just pass the component to it. So whenever Webpack tries to generate a bundle, whenever Webpack bundles it, it imports the file into the main application and then links it. So it creates a big bundle there. I've used another API called get component API, which is a callback which gets executed. And in the get component API, you use something called require.ensure. Require.ensure, whenever in Webpack, whenever it sees require.ensure, it creates a new file for whatever is included within it. So inside require.ensure, you can see I'm actually requiring another file there. So what happens is that particular file is created something called homeview.js. So you have a different files created for a different route. So you can do that for every route, and when you go for that route, you can load that. So that's how you do route-based chunk. Another way is intent-based chunk. Intent-based chunk is tricky. It's based on the data, where based on users' behavior, you load the files. For example, it could be a click and scroll, or any of the users' behavior, you load the file based on what would user now go for it. So this is a screenshot of booking.com, the search result page. So for example, let's say we have a big search result page and which has all these files, and let's say we have a data saying that out of 5 sessions, only once a user clicks on the map button there. So there's no point loading the entire map.js for all the users. So what we do is we create a bundle from that instant separately for map, and only load it once he goes to the map. So this is part of the same route, but it's a different chunk which is loaded only after a click. So this is that. If you make it a separate route in the map, then it could be a route-based chunk. But here it is part of the same route, but it's a different content. So after this, I had a big improvement, of course. Yeah, 19 seconds to 4 seconds, because earlier I was loading all the JS which is needed, the entire file, which could include the vendor, which includes all the different routes altogether. Right now I am loading only the vendor and the first route which is needed. So this was the improvement. The second one is the server-side rendering. Everyone knows it. Server-side rendering is, I've used Express here, pretty straightforward. If you see here, I've used the Express API, where all the request which you make, which comes here, and I use the match API of React Router, where based on the request URL, I match with all the routes which I have. It's the same code as for the front end, so it's an isomorphic code. So I match it with the existing route, and I render the completely using render the complete DOM using render to string. Pretty straightforward. And then build that entire DOM and pass it down to the client. So what advantage I have here is when the user gets the DOM, the person doesn't have to make a request for the JS and render the first screen. Instead, the first screen is already available because that's what you get from the server. It includes the CSS, the basic layouting, and the next JS interactivity would be delayed, that would be requested from the server. So after this, the first meaningful paint took 900 milliseconds from 4 seconds. So that was an improvement, because the user don't see the white screen for a long time, you immediately see the content. That's why back in the previous demo when I showed you that the Uber logo came really fast. So that was because, and Uber logo was a CSS made one, it was not an image. So I didn't have to make a request for the image and load it there. It was just a DOM with this basic CSS there. So that's why it's 900 milliseconds to see the first content. Second one is serving compressed static. Yeah, everyone would have gzipped your static files, but the performance, what you would get here is what I'm going to talk. this was all the files which was generated by me, but here we'll be looking at only the JS files. So I don't know if you can really see it. So out of these 6 files, in the first render you only need three JS files, which is the vendor, the app level JS, and the route level JS, which is the base view. So now what happens here is the vendor has a lot of React, Redux, stuff like that. So there are a lot of other optimizations I can do here. For example, I can isolate the React Redux that is not needed in the initial render. I can just pass the base view and a small amount of vendor to it, and then asynchronously load other JS files. So, but for my app, it wasn't really important because I didn't see much of a difference doing that. So I went to loading these 3 files directly. But otherwise, if you see a lot of, you can actually see a lot of improvement if you load only what is needed, only the vendors what is needed, and only the code, only your code what is needed. So this gave me a slight improvement, almost 50%. So it came down to 546 milliseconds. So this was my final time where I couldn't optimize more than this, but yeah, you can actually go pretty much after a while. I think after a user sees in 500 seconds or 300 seconds, not much of a difference. So we got to know where to draw a line on optimization also. So this is where I prefer to draw my line. It's 500 milliseconds. Then I try to work on things like repeat visits. Repeat visits are tricky because you need to cache your assets. There are multiple ways to cache. This is where the progressive web app came in. So my interest basically started from what I wanted to do. I ended up doing this for this small part. So that's caching. I've tried 2 ways. One is I've used service worker toolbox here. I don't know if you can see it from that far. I can read it out for you. It's a toolbox.router.get. So any request you make on the JS, or any request you make, any network request you make, it first goes through the service worker. This one. So I've said that star.js, any JS files, I need to do a toolbox.fastest, which means I make a network request. I also make a cache request to a cache. So whichever is fastest, I serve from there. So there are ways, trickier ways where sometimes the network request is faster than the cache. Like for example, you're offline and it's a 404 on the server, and on the cache it is not. So you got to handle those issues. I've not shown that, but those are something which you can see, because sometimes the cache is faster because it's undefined, and the network is actually. So what do you want to show? So those things actually Toolbox handles this internally, but you can write your own code also and do that. And there's something called SW pre-cache, which I've not used it, but that also helps you cache the files for a while, and you don't have to do any of these aspects. So there are a lot of wrappers for service workers which you can use and not go into the literal of service worker. This is all the 6 to 7 lines of code I had to write to make it offline accessible for my application. Maybe it's complex for other applications, but for my application this is all I had to write. And for the browsers which don't support, I went the traditional way of setting an expire header. That's it. So for browsers who don't support, I use a browser cache and store it there. So with this, it gave me a slight improvement on the repeat visits. So usually, as I said, it took 500 milliseconds for my first visit, and after that the repeat visits were the same because it was not caching, and after caching it used to take 300 milliseconds. So yeah, it was a 200 millisecond improvement on my repeat visits. So this was one. Another one is preloading assets. This is very tricky because you tend to preload all the assets which is needed before the actual need of the particular assets. Where, for example, there are multiple ways. One is DNS prefetch. How many of you have tried preload? No one. Okay. You have tried. Yeah. So there is a funny way called DNS prefetch, where what you do is, if you are sure that, if you know that your assets are from one of the CDNs, you can prefetch those DNS. So all the DNS lookup would be done before that. It's a small time, very little millisecond, but all of that would be done before the actual request is made. It doesn't do a lookup of all of that. Similar to that is the pre-connect. Pre-connect does the DNS lookup, but also does the handshaking and stuff like that. So it's a little more than that, but I don't see much of an improvement here if your assets are from the same domain as your site is hosted, then you don't really need it unless your assets are from a different domain.
I believe you should notice the difference if you have SSL there, if you're on HTTPS, because like then currently it establishes the
the pre-connect establishes the network before that.
Okay.
But the previous one, as I said, prefetch doesn't establish the network, but it just resolves your DNS for that. It does a DNS lookup for that. The third one is a prefetch. Prefetch is something where, for example, if a script tag is needed after probably next route or something like that, you prefetch all the assets now. So it makes a network request, it stores in the app cache or the service worker cache, and when the actual request goes through, it loads from the cache. It doesn't make a network request. So this is something, if you know what assets are needed, you actually do this. But there's a problem with prefetch is its browser's priority. The priority is very low. In Firefox, the prefetch is only triggered when the browser is idle. And so this is one of the problem, and browser can completely say no to prefetch and go ahead with its normal one. So this is the problem with prefetch, but you can do that. Pre-render is the most dangerous one and the most useful one. So for example, if I'm in the search result page and I know that the next page would be a hotel page. So what I do is I load the entire page in an isolated tab. So that's what pre-render does. I load the entire domain in an isolated tab, load all the assets which is needed for that page. So it technically loads a different tab. So when you actually go for that page, it swaps the tab. So as a user, you don't see much of a loading there. But you have to be very careful because you have to be very sure that user would go to that page. Otherwise, you'll be loading all the unwanted assets which is needed there. So that's pre-render. So another one is preload, which is similar like the prefetch I said. But here, preload is the priority. It will make a request. But preload is a new API compared to the prefetch. So what we usually do is I write the preload, and as a fallback I write the prefetch, so that browsers which don't support preload fall back to prefetch. Yeah.
Does pre-rendering make any sense if you are rendering client-side, which like a single page app does?
If it's a server-side rendered, if you know what the content, if the assets are, that's what you need. So if you
if you're client-side rendering the next page, so you're using React router on the client side, and you're not actually fetching.
You can actually load the chunk of that route.
Yeah, you would only load the JavaScript.
Only the JavaScript. You can make render the page which only loads that particular JavaScript. Yeah. So preload is something similar to the prefetch. Yeah, that's what I said. Yeah. Going. So there were other ideas which I wanted to do on this app, but which didn't really make sense for me. But I want to talk about them. One is HTML streaming. So HTML streaming, we all know how the waterfall is. So the DOM is requested, it starts passing, it gets the CSS. Once the CSS is there, the render starts. And once the JS is complete, then the actual interaction starts. So this is the actual waterfall. So what we actually do here is we send only the part of your HTML first. Here you can see, I don't know if you can see, but the body tag is not present. So where you only send the head. It's also called head flushing, where you only flush the head first and load all the assets which is needed, and then after the assets are come, which using the preload I'm doing it, so it's not executing the assets, it's just loading them, and after that then I send the entire HTML, so with the body tag, the actual script tag. So here for my file it is not much of a difference. You can see I send 4 KB of a file, and then after that I send the 15 KB of a file, but sometimes your HTML can go up to 50 to 60 KB, then you can send a small amount of a chunk, and then, but there are a couple of problems like opening the 2 different network connections. So you got to see which really works for you and then go for this. So whichever works for you. Another one is HTTP2. I know everyone's speaking about HTTP2, advantages about that, yeah. So this is something which I wanted to try, but not many CDNs or not many servers support it. So giving a bit of an introduction about HTTP2, this is the one of the image which I thought resembled HTTP2. So HTTP1 is just a single request, HTTP2 is parallel request. I don't want to go deep into it, but a very simple explanation. So if you have a lot of assets loaded, images and things like that, one thing is to divide it into different CDNs, different subdomains, so that for one domain the browser sets that 6 requests or 4 requests or things like that, so you can put it in a separate domain. But if it's in the same domain, the advantage is using HTTP2 because all your handshaking thing would be done only once, and all your files is loaded parallelly. But there are a lot of problems like on a slow network, packets are lost. Yeah, that's a different talk altogether. But you can actually see. But if your websites from all over the world, you will have trouble because there are a lot of requests coming from HTTP 1.02, not just 1.1. So you got to tackle them. So basically, my talk is all about the blog which I wrote recently. So this was a blog which I wrote how I made a super fast clone of Uber clone of mobile web. You can actually go for this blog. This is the link for it. Write it down. Yeah. And the work which I did, the repo is on my GitHub. The code, not really proud of the code there. The React was written really fast just to test out my techniques. But you can really go and see the techniques which I used to make it fast. So that's one of the things. Like I mentioned, my slides is there on that link, and that's my Twitter handle. So if you guys have any questions or anything to discuss about the performance, please feel free to ping me on Twitter. And yeah, it's an open-ended discussion because any performance improvement is not the right way. Everything is the right way basically. So if you have any ideas, anything to talk about, you can always tell me. Yes, I am open for questions. Yeah.
You mentioned tricks with a link as script, prefetch, prerender, preloader. For example, for preload, why script differ worse than this trick?
Yeah.
What is this trick?
Yeah, so the thing is, for example, let's say I am not in the search result page, but I am in the home page. So I preload the script which is needed for the search result page. It could not be just for the one page.
Yeah.
I could load any different assets. So if you know that I need it for the next page, then I load it in this page itself.
And it's cached, right?
It's cached. So based on your caching techniques, it gets cached in the browser cache or the service worker cache. And next time when the actual request is made, but this doesn't execute the code, it just makes a network request and stores it. When the actual request is made, it gets from the cache and executes it. There are a couple of ways to do it. One is with the React router, like I mentioned, the get component API, where you make the actual request. So there parallelly you can make a request for your chunk too. So if you know that next route would be that, you can actually make it there too. So there are a couple of ways to handle it. I felt this was the easiest way. If you know which chunk to load, I'll just do a preload.
But have you tried script differ to load your vendor assets and library and your base component assets? Have you tried?
Yeah, but the thing is,
render,
after the actual passing and render, script differ really executes it. It loads it and executes it. I don't want to execute it. I just want to keep it in my browser cache and actually execute it on a later time. I hope I answered your question because script differ, after it makes a request, it waits for the HTML to be done and then it executes it. I don't want to execute it now. I want to execute it on a later time, then I do this.
Yes, that's for next page.
For the next page. Yeah, for the next page. It's mostly for the next page you see. So all the preload which you see there, it's mostly for the next page unless the DNS lookup stuff.
But for the home page, for the landing page,
yeah.
Why don't you use the differ?
Why don't I use differ? Okay, I've used differ in my thing, but it didn't really make much of a difference for me because already the DOM was rendered and the script, what you're saying, it didn't really block much. When I did a performance thing, I didn't have much of a gain of using a defer there for my application.
But user gets the feedback already, like they have some rendered HTML, so they don't have just logos, they have the complete layout.
Yeah, the complete layout, what it was waiting for that was for the map thing. As you mentioned, yes, you can actually put it on the head and make a defer, that's what you're saying? And then after the page is loaded, yeah, I can actually try it out and see how it works. But I tried it out in the body tag. It didn't really have much of an impact for me. So I didn't go with that.
You should put it in head.
Yeah. I think I should try that.
Right, sorry, let's do another question, and then
Sure.
we can, of course, catch Narendra for the networking session, or yeah, you can use his Twitter, which is not as long as a link to the slides, but so right, one more question, and then we proceed
Yeah.
with the second speaker.
Anyone?
How long did it take to build this app?
It took me a couple of weekends. I think 3 weekends. 3 weekends, yeah.
And how many hours per day in this case? You spend 6 whole days, it's 24 and 6.
It was 4 to 6 hours maybe per day.
Okay.
Oh.
4 to 6 hours.
That's still pretty fast. Okay.
Yeah, that's why I'm not proud of my code.
But Uber would like.
Yeah, Uber, yeah, maybe.
Right, thanks Narendra for the talk.